YouTube. I am going to give you a quick and easy example of what RMS voltage and what RMS current is. A lot of people don't understand why RMS, but right here, I'm going to use the power of Excel to demonstrate to you what RMS is and why RMS. And I'm going to start initially with DC, and DC is the easiest way to start this off because it's all direct straight lines, direct current. So if we start with a DC voltage of 10, and let's say we're going to put it across a resistor, a 2 ohm resistor, we'll get 5 amps. You can see that right here. I got a blue line for voltage, I got an orange line for current, and if you multiply voltage times current, you get power. We can see that a voltage of 10 volts DC will create a current of 5 amps through a 2 ohm resistance, and you'll get a power of 50 watts. I just want to note that the peak power here is 50 watts, and the average power is 50 watts, obviously, because it's a straight line. So let's move on to AC now. Oh, actually, before I move on, I just want to show here with this little chart, that this graph I have posted here, it is just voltage, current, and in every time instance, I multiply the two, so you can see E3 times F3, 10 volts times 5 amps is 50 watts. It's the same thing I'm going to do over here in AC. So I got a tab for AC. Let's say we have a sine wave, which is what AC is, and we have a peak voltage of 10 volts across, again, a 2 ohm resistance, and we get 5 amps. So right here you can see that I'm going to take this, I got the power turned off. So if we take them two and multiply them, you'll see that we get a peak power of 50 watts. That is actually what's happening. If you put this on an oscilloscope, at every time instance, I increase the voltage like a sine wave would increase. I put it over a resistance of 2 ohms, and I show you what the current is. It's slowly increasing to a peak of 5 amps, and the power peaks out at 50 watts. But the thing we got to remember here is that the power peaks at 50 watts. If I were to take the average of all this power here, I actually did it on the bottom of this Excel spreadsheet. If I take the average of this, you can see it's 25 is the average. Average of all the power distributed over that one cycle is 25 watts. Average power is, it actually works out in sine waves that the average power is half the peak power. So in this equation, the peak power is 2 times the average power. That's how it works in sine waves. I just demonstrated that in Excel. So the last thing I'm going to do here is throw some equations at you to throw it all together. If I take voltage peak times current peak, it equals power peak. I displayed that before. And power peak is the same as average power times 2. In sine waves, I also explained before that the average power turns out to be half of the peak power. So if I divide both sides by 2, we can see that voltage peak times current peak divided by 2 equals average power. And whatever I do to voltage, I must do to current under a constant resistance. So I'm assuming, and in these examples, the resistance is constant. So I can split that square root of 2. I can split that 2 up into both the voltage and the current, and they can be proportionally split up by the square root of 2. So voltage peak divided by the square root of 2 times current peak divided by the square root of 2 equals average power. So one day some guy measuring decided, hey, instead of doing voltage peak and dividing them by the square root of 2 every time to get a comparable power output like we would if we would compare it to DC, we'll just call this voltage RMS. So if we take voltage peak divided by square root of 2, and we're going to give that a new term, we're going to call that voltage RMS. And current peak divided by the square root of 2, we're going to call that current RMS. So right here we can see up here, I made Excel do some nice little math. We got 10 volts peak over a 2 ohm resistance will create 5 amps peak, and it'll create a peak power of 50 watts, which is pointless to us. We want to know average power. It's the average power dissipated by a heater or resistor. And that is actually half. So if we take that peak and divide it by the square root of 2, we will get an RMS voltage of 7.07, and over a 2 ohm resistance, we'll have an RMS current of 3.5. which actually does equal an average power of 25. So now we have a value that will give us the same average power as if it was DC voltage and DC current. Just to make this easier to understand, I'm going to change the RMS voltage to 10. You can see 10 times 5 equals an average power of 50. With an RMS voltage of 10 and an RMS current of 5, we will get peak powers up to 100, as you can see in this Excel spreadsheet. But the average power is the power that we care about, and right here you can see that. So if you guys take an oscilloscope and measure 10 volts AC, you will see it peaks out at 14 and has negative peaks at negative 14. It's exactly what is happening. And that is why the RMS voltage is the square root of 2 smaller than the peak voltage, and the RMS current is the square root of 2 smaller than the peak current.